Hello, and welcome to the Semiconductor Industry Association's public webinar series, where we address current issues impacting the global semiconductor industry and market. My name is Falan Yanug, and I am the Director for Industry Statistics and Economic Policy at SIA, and I'll be your host and moderator for today's webinar. As anyone who has ever driven in a new car can attest, today's automobiles are essentially computers on wheels. Gone are the days when the only thing electronic in your vehicle is your radio. From heated seats to electronic windows, to knowing the best gas mileage and how long to keep fuel injectors open, to the standard array of safety features, today's cars are arguably more computer than steel. This computing power is, of course, powered by semiconductors that are packed within today's modern vehicles. Here to discuss the importance of semiconductors in automobiles, how they are transforming auto technology, and the future market growth of this important end segment are four distinguished panelists. Mr. Richard Robinson is Director of Automotive Infotainment and Telematics Service at Strategy Analytics, where he leverages over 10 years of industry experience to create highly detailed analysis and forecasts of automotive systems, semiconductors, and service markets. Mr. Heinz-Peter Beckmeyer is Director of Automotive Systems at Texas Instruments. Heinz-Peter has held a number of roles at TI, where he started his career in 1994 as an application engineer, and he is currently a TI Senior Member Technical Staff Emeritus. Mr. Bill Stewart is Senior Director for Vehicle Automation and Chassis at Infineon Technologies. He has worked in the semiconductor industry for over 15 years in various business development roles across applications for the entire vehicle. His work includes engaging global teams to drive new product and application strategies for future automotive innovations. Finally, Mr. Ross Seymour is Managing Director at Deutsche Bank Securities. He has covered the semiconductor device sector since joining the firm in 1999 and has been a sell-side analyst since 1993. Richard Robinson, why don't we start with you? If you could give us a big picture view. Where are we now in terms of chip technologies in cars, and where are we going in the future? What does the future look like?
Best to get off mute. Thanks, Lan. Yes, it's an interesting time. We're coming in at this at the end of a very interesting year. I'm afraid we'll get some of the bad news out of the way first. Obviously, this year has not probably been a good benchmark for what's happened in the industry, fortunately, of the last few years. But generally speaking, the general headwinds in the market are pretty substantial. We have trade wars, we have Brexit uncertainties here in the UK, the German slowdown, WLTP issues, Dieselgate, not to mention COVID-19 as very much headwinds for everyone in the industry. This is not just the chipset guys, but I think the really positive thing that's come out of this, and we'll see more in this presentation as we move through it, is the fundamentals remain strong. Content in the car continues to grow, and that's a very strong positive position for the future. Electronics still relatively underpenetrated in most vehicles worldwide. But there are some key trends that we need to be concerned about, one of which is this idea of domain collision. We'll see a bit more of that as I go through, but the idea of moving away from individual boxes and features, doing a single function towards something that's much more multifunctional and driven by software has positives and negatives. It's strong for the chipset guys in particular if you kind of win the business, but probably not so great if you're more reliant on more traditional approach to manufacturing. So really the key points, safety is touching everything. The idea of functional safety really, from my background, an infotainment telematics guy, was something we really didn't need to deal with when I was in the industry. And the more siloed your company is, obviously the slower you're going to probably be to recover. But if we look at the main suppliers into this market, whether you're an electric vehicle supplier, looking at connected car, ADAS, autonomous shared mobility, or data services, the idea of the older style architectures is changing. We're looking at a new, very much digitally oriented architecture, moving away from kind of mechanics towards electrical. And if we look at where we are today in the period between up to a year 20 to 2022, we've seen a very much a distributed architecture, as I said, with lots and lots of boxes. Kind of came to the peak in the Volvo XC90, I think, in about 2016, which had about 120 separate ECUs. Those days are kind of very much gone, and we're in a critical period of change now as we move towards what we describe as a domain controller architecture. The area I cover in particular, which is the infotainment telematics space, is most affected, earliest. But with the rise of things like cockpit domain controllers and combination functionalities where one box is driving multiple functions. But that's just a stepping stone towards further integration in the electronics and electric architectures. What does that mean for the suppliers in the industry? Very much shifting away from this idea of a chain of semi-vendors, tier twos, tier ones, up to the car makers, all the way to what we describe now as a kind of a mesh, supply chain mesh, where you're seeing interactions between companies which we haven't really seen before, and in particular much closer ties between the chipset vendors and the OEMs in a way we haven't really seen in the past. It really has kind of we have now got regularly situations where car OEMs are specifying which chips they want to have in their systems, which is certainly not the case when I was in the industry. Then we throw in a very large cannonball into the whole thing, which is the what's happening on 5G and the requirements from that. If we just look at this, is not from our automotive service in our company. This is from the wireless service. But the growth in 5G cannot be overestimated. If we look at down the left-hand side over here, the number of launches that have happened of 5G by quarter, and compare that to say 4G and 3G, and we were talking about 60 launches in a matter of 7 quarters. This is a technology that is really growing very strongly, and it behoves us in the automotive industry to look at this as a game changer in terms of the opportunities, in terms of data, not only to the vehicle, but what would be put off the vehicle for use outside. And we'll go into that, I'm sure, a bit later. In terms of the outlook, not a great year, probably one we want to put behind us. Steep declines, and really at one point, I mean, it was about a 20% decline initially that was forecast for 2020, but fortunately it's been revised up to about 17%. So pretty well across the board and across all countries, a pretty lousy a year really. But then we start digging a little deeper and see that the sub effects are really quite key. Certain market areas, if we look across here, conventional engine, transmission, chassis, conventional safety, and driver information have been hit pretty hard, 15, 17, 20% falls. But other areas over here on the in terms of hybrid and electric vehicles and in terms of ADAS, we've actually seen positive, either flat or positive growth in quite a declining market. So it depends on which kind of horse you have in the race, really, in terms of how you've done really in 2019. If we look at what's happening in plug-in and hybrid electric vehicles, I thought I'd put this little plug in for the UK market. Plug-in car sales actually overtook diesels last month in the UK market. I mean, that's quite a thing to see in the market this early on, where obviously this is a sign really of things to come as we move towards a much greater electrification across the board. In terms of a recovery, I think we're all very pleased about the fact that this is over and hopefully it can't get any worse. But the general movement is back to about 1.8% growth in terms of vehicle production over the period of 2019 to 2024. And China, once again, being, as it was in the previous financial crisis, the country that we're all relying on in terms of strong growth to kind of help us pull ourselves out of this the mess that we've got into. In terms of individual semiconductors, quite clearly the high growth areas have been from safety and powertrain. You can see across the range over here, the compute side and the opto side in particular have done very well, or will do very well over the next few years. But we're expecting an average growth rate of about 8% over that period of time. So it's very strong and very much against the trend, as we saw earlier, of only kind of 1.8% in terms of vehicle growth. I'm very pleased to say after this pretty abysmal 2020, 2021, with forecasts dropping about 15% generally across the board, 10 to 15% in terms of chipset revenues. The growth is very strong in 2021, and while it does tail off in terms of growth, and we're talking about growth of near 25% for next year, so very, very strong opportunity for the suppliers. The issues, of course, is that certain markets and certain categories will do particularly well out of it. China and ADAS, if you kind of want to get to a peak of where things are really happening, China growing from 13% of ADAS demand in 2017 to 27%. The thing about it is it's 27% of a lot of cars, by far the biggest market in the world. So that's definitely a headline that needs to be followed through. Chip shortages, I'm going to wrap up now, but chip shortages do point to a pretty turbulent year. This is not only VW, but other manufacturers, and we've seen some of the chipset manufacturers saying they're going to be quite blatantly going to be putting up prices, perhaps slightly misled by some feelings in the market about how bad 2020 would be, and quite significant cuts in production earlier on this year on the chipset side has meant that tier ones and OEMs are really scrambling to try and find key enabling technologies to build their vehicles. So it's a good news thing, really, in the fact that we've outstripped the terrible forecasts that were coming out. If you remember back to February and March, we had parts of the world where the production was down 98%. So it's really a significant turnaround, which is great news. So that's kind of my a layout, really, of a kind of whistle stop of what's happening in the market and what we kind of have to look forward to.
Perfect. Appreciate that, Richard. That was very helpful. Let me go ahead and turn to Heinz-Peter Beckmeyer of Texas Instruments. Heinz, give us a sense. TI is one of the leaders in producing chips that enable automobile technology. Can you give us a little more sense about the type of work that TI does in this space?
Absolutely, Fallon. At first, hello, and let me thank you for allowing me being with you today. I'm Heinz-Peter Beckmeyer, and I'm Director of Automotive Systems at Texas Instruments. I've been with TI for 26 years within the semiconductor market. More than 10 years on the engineering side. Actually, in that time, I was a senior member technical staff, and for the last 6 years, I've been directing our automotive systems group for TI. Now, if you could switch to the next slide, Fallon. Texas Instruments, to give you a few comments on Texas Instruments, TI is one of the largest semiconductor companies. We engineer, manufacture, test, and sell analog and embedded semiconductor chips. And these chips, they are present in all different markets. Today, we talk about automotive, but we are deeply in the industrial field, whether it's on automated factories or whether it's in the medical market. You can basically say our products are at work in virtually every electronic system. This is clearly our strength with our breadth of the portfolio. However, a big focus for us is in TI, the automotive market, where we've been a player for more than 30 years when we started to develop products for the passive safety systems, such as braking and airbag, as you can see as well here on the slide for passive safety systems. And we help there to increase the passenger safety. Ever since, the automotive market has been and will continue evolving and innovating for the years to come. We saw earlier the numbers of semiconductor content as well, how it's going to grow. That's an excitement, but also from an automotive point of view, it's an excitement. I'm sure you're sharing the same excitement I do. When you look back 10, 12 years ago, consumers actually decided to buy a car maybe because of an exciting LED daylight design, right? Or today it might be the automated parking someone is interested in. So there is an innovation over the years which is going to continue. And TI is the partner in the system innovation in all of these sectors, which you can see here on this slide. And there are, inside these sectors, there are more than 150 different type of applications within these sectors. And TI is basically coming with a breadth of a portfolio with more than 7,000 automotive qualified products, enabling really our customers, whether it's like on the body electronics and lighting side, to simply optimize comfort and convenience with systems like heated and cooled seats. There are other things. When I talk to my wife, to have an anecdote here, she has the most favorite application, which is a contactless electric trunk opener. Everybody has his favorite here, right? Or we talk about the increased safety through vision systems and cameras and radar on the left side for advanced driver assistance systems. And on the right side, last but not least, the hybrid and electric vehicles. It's obviously our goal to help reduce emissions while increasing the efficiency through electrification from the car to the grid. Today, I would like to spend a few minutes actually on the electrification, vehicle electrification. And with this, Fallon, I would like to move to the next slide. There are different vehicle types which represent the roadmap to the right side where you see the zero emission. And reducing emission is the name of the game. Car OEMs, they have to meet global government regulations on emissions to avoid penalties. To meet these government regulations on the individual car basis and fleet average, car OEMs follow different strategies and introduce different vehicle types, as you can see here on this slide. On the very left side, you can see what's called the micro hybrid vehicle. And here we've got the 12-volt battery, we have a start-stop system, we have very limited recuperation. It's the state-of-the-art technology for some time already. And when we move one further to the right, the mild hybrid, here we have 48-volt systems. It allows us to downsize the internal combustion engine, add some electric torque, and a limited electric propulsion as well. You can see we have a few further end equipments or applications in there, like a DC-DC converter, obviously 12 and 48 volt, and we have also the first battery management system also in here. When we talk about the full hybrid car, this is where we have even more CO2 reduction through a larger battery and an electric-only drive mode. In most cases, really driven already by a higher voltage battery. Adding then an onboard charger makes it a plug-in hybrid vehicle. The recharging happens through the onboard charger and from the grid, the main supply. And the increased mileage is defined by the capacity of the battery at the end. Then when we look on the right side, growing area, obviously the battery electric vehicle, entirely propelled by electric motors, no internal combustion engine anymore, zero emissions on this side, and these electric vehicles are operating typically off a high voltage battery. In this domain, we have a couple of really key trends which are fueling as well the semiconductor opportunities, which are fueling as well the future here on the powertrain side. Fallon, if we go to the next slide, we have a couple of key powertrain trends. And this means in addition to the different strategies for the amount of electrification, there are these trends which we are seeing today, and they enable either a lower emission or a higher mileage, and also a lower cost to make electric vehicles more affordable, which is important for all of us, obviously. And TI's product innovations and our in-depth system knowledge as well, and they really enable these trends. On the left side, you can basically see adding power with 48 volt. The 48 volt rail is added to boost efficiency, and as such, the vehicle ranges. And as we saw earlier, walking through the different vehicle types already. And it manages power-hungry loads, such as heating and cooling systems. They can be in the 1.5 kilowatt range and above, and or automated driving controllers, and which will need more and more computing power as we move up in the level of autonomous driving as well. Last but not least, it'll help the transition also from lead acid to lithium-ion based batteries. In the middle, we can see evolving battery management systems. And if you think about evolving battery management systems, they're obviously only for a certain number of years today in the market, but we are talking already about the next step here, because the range at the end is a very important criterion for us. Wired battery management systems is the proven industry standard method today. And the choice for tier ones and car OEMs implementing our devices with a wired daisy chain communications interface today. We are talking today, though, about the evolution here on the battery management system side going wireless, which can help us to improve reliability. And when you look at it, leading failures today in the battery management side, they occur with a wiring harness and connectors according to our customers. And secondly, it reduces significantly the vehicle weight to boost the efficiency. It's very hard to imagine. However, there's more than 3 miles of cabling in the car, which can be eliminated by going for a wireless BMS system. Last but not least, this allows us as well for a higher flexibility, simpler design and placement within the vehicle, which allows us to scale and to help making electric vehicles more affordable. On the right side, you can see the integration of powertrain applications. Systems are trending towards a certain integration level. Today, we talk about typical applications like a traction inverter, a DC-DC converter, battery management system, and onboard charger. And there might be a certain permutation in terms of an integration to come. The integration improves power density, reduction of weight, and it increases reliability and optimizes cost as well. Texas Instruments accelerates this evolution through innovations on the component side. There are ISO 26262 functional safety compliant devices, such as isolated gate drivers or isolation technologies for high voltage. Most recently, we added actually a highly integrated gallium nitride offering, which helps us to add more power without drastically increasing vehicle weight or cost. And the gallium nitride fast switching speed increases efficiency, resulting into high power density, lowering weight, and ultimately a higher vehicle mileage moving forward. Now, let's look at the overall breadth and portfolio, the opportunity we bring to the market. Fallon, if you move to the next slide. Here on this slide, I talked earlier about the 7,000 plus analog and embedded products. And this slide shows you the extensive portfolio offering from TI for each major building block of a typical electronic system, ranging from analog signal chain and power management through embedded processing products. When you look on the right side, you can see, for instance, on the right bottom side, battery management, high voltage power. This is what we addressed earlier, vehicle electrification or wireless battery management systems. This is where we bring the portfolio in these applications to the market. You can see above power management device for all different purposes, also power switches, which are used obviously all over in the car in body control modules and other applications as well. You move to the next, to the left side, wireless connectivity goes together again with wireless BMS systems, car access systems as well. And you see other areas which you can see like DLP products, which can go into external headlight applications, which you can see on the roads today, or in other display opportunities. Sensors, obviously, as well, our radar portfolio as well. We looked at the ADAS growth numbers as well. sensors are about to grow. This is an area where we are playing an important role as well here on the sensor side and beyond. Magnetic Hall sensors, current sensors as well. These are components which are needed in all kinds of different applications inside the car for HEV, EV systems. When you look at traction inverter, again, you need to measure currents, where you need to measure voltages as well in order then to make the right decisions. You look at motor drivers, needed as well on the HEV, EV side, on traction inverter, however, as well on the body motors and body electronics and lighting side, whether it's for seats, for example, or for windows. This is just an overview, which I wanted to give you from the product overview side. You can learn more at ti.com. The link is shown here, highlighted in the bottom of the slide for vehicle electrification as well.
Great. Thank you, Heinz-Peter. I think the word that really sticks out to me when you talk about TI's role in enabling cars is just that word enable. A lot of folks, I think, who drive cars don't necessarily know what TI and companies like TI and Infineon do behind the scenes in your car. So really helpful to sort of see that illustrated. Speaking of Infineon, I wanted to turn next to Bill Stewart, who is with Infineon Technologies, another major chip manufacturer who is providing and enabling our vehicle technology these days. Bill?
Thank you, Fallon. So what I want to talk about today is a little bit more about what we're doing for automotive portfolio, and not just about the chips, but what we're trying to do to enable them at the system level as well. So at Infineon Automotive, our goal is to shape the future of mobility with microelectronics, enabling clean, safe, and smart cars. And that's really the key, right? We talked about some of the trends earlier, but ultimately these are the three end goals that we have to accomplish. Clean applications consist of improved efficiency of combustion engines, as well as enabling electrification. Safer cars will be developed through the increased adoption of ADAS systems, as well as trustworthy occupant and pedestrian protection systems. And smarter cars are developed through better convenience features and ensuring secure connectivity both within and beyond the vehicle. Our passion for innovation allows us to offer the industry's broadest portfolio of products, which cover the entire range of automotive applications. In addition to our traditional portfolio of sensors, microcontrollers, and power products, the recent acquisition of Cypress has further strengthened this offering with memory, connectivity, and additional processor and sensor offering. This allows us to take a chipset approach and offer a high system level of understanding to our customers. Cybersecurity, functional safety, and high quality are all ingredients that can be found across this entire portfolio. As you've seen in some of the other presentations, ADAS and autonomy are one of the key growth drivers for the automotive semiconductors. The higher level of autonomy, the more chips are needed. Already today, almost half of the vehicles being produced have some ADAS features in them, and level 2 and above applications are going to be the primary market driver in the near future. These systems require multiple sensors and processing modules, further increasing the system level complexity and vulnerability to both intentional and unintentional errors or attacks. Reliabilities of these systems will be a challenge of ever increasing complexity for our customers. You can see in the slide here, a level 2 vehicle has 3 or more radar sensors, at least 1 camera. A level 1 or level 0 vehicle, you may have 1 sensor. Right, so you're already seeing a multiplying effect on a level 2 vehicle, and that increases even more as the level of autonomy increases. However, we have seen a shift in the autonomous vehicle market. It's become obvious that the tech race we see all these developers pushing is not just about technology advancements, but also trustworthy systems need to be accepted by consumers. 3 examples of quotes that we've seen from the industry come from Cruise, Intel, and Argo. The first testimonial underlines that technology and trust are inevitably intertwined. The second one emphasizes both trust and technology are important. And the last quote shows that trust is the prerequisite for adoption and part of the foundation of their design. In order to achieve this successful combination of both trust and technology, dependable electronics are required. So what is dependability? On this slide, you see a generic definition, the quality being trustworthy or reliable, trust and safety. Semiconductors are a basic building block to create trust in the context of autonomous driving. All levels of automation, but especially the higher levels, such as level 3, 4, and 5, require the passengers and drivers' trust for its adoption. Would you be willing to switch off your brain in a level 4 vehicle if the system only provides limited functionality in case of the failure? For level 3, are you comfortable re-engaging with the vehicle on less than a minute's notice if you're sleeping or not paying attention, you're reading a book on your phone? Or do fail operational systems with less dependable semiconductors really provide the requirement of developing trust with the driver? The answer is no, and this is why dependable electronics become important. Dependable systems are at their core an expansion of what we see today with fail-safe and fail operational concepts. Fail-safe approaches in the vehicle are used in lower level of ADAS systems. If a failure occurs, the system enters a safe state, but may not continue to function. Think about your power steering system. You may have to revert back to manual mode instead of having the power assistance. Fail operational are used in the mid-levels, so the level 2, level 3 type vehicles. If a failure occurs, the system continues safety critical functions and maintains some form of degraded functionality for a specific amount of time, but ultimately keeping the driver safe. High availability systems are needed for all levels of driving, but mandatory for the higher autonomous levels. If a failure occurs, the system continues to be available and protected against security threat. The result is a dependable system, fail operational, secure system with high availability. So the foundation of all of these dependable systems start at the component level. This enables reliable modules for our tier 1 customers and allows for the development of dependable systems and subsystems. These are required to create a safe autonomous vehicle which can interact with its environment. Infineon leverages a deep system thinking from components to systems and thus enables trust in all driving conditions based on dependable components, modules, subsystems, and systems. Cybersecurity, functional safety, and automotive quality only go so far on their own. The key to dependable system is to combine those building blocks with our passion for innovation, system and application understanding, and the desire to act as a trusted supplier. Our passion for innovation is amplified by the advanced technology and solutions that we offer. System understanding drives the right, not over or under engineered solution to meet customers' requirements and build upon fail operational systems. And we've developed a reputation as a trusted supplier through ensuring customer business continuity and providing a premium service experience. The combination of all these ingredients is really what enables the automotive mobility innovation and makes semiconductors the basis of that. Thank you.
Thanks, Bill. Appreciate that. I really like the way you mentioned clean, safe, and smart as sort of a way to think about what semiconductors are doing in your car at the onset of your presentation. Clean, safe, and smart, definitely sort of a framework for thinking about the enabling feature of semiconductors in vehicles. Finally, let's turn to you, Ross Seymour. I know many folks may not realize this. Obviously, I'm sure you do since you cover the market very closely. But semiconductor sales for automotive end use accounts for a pretty big chunk of overall sales, around 10 to 15% annually. The only thing greater in terms of areas are computers and communication devices, cell phones. Now, 2020 has been, as Richard alluded, a crazy, crazy year for the semiconductor market in general, but even probably more so for the automotive end market sales. Could you maybe, in your opening remarks, take some time to help us understand and walk through this year and how it's played out? Obviously the pandemic has been a major impact, something we didn't think about, before the beginning of 2020.
Sure, and thanks, Fallon, for having me here. Happy to talk about that. In general, I should start by saying I've covered semiconductors for about 20 years, but for 5 years prior to that, back in my home state of Michigan, I was actually an automotive and auto parts company analyst. So I have a soft spot in my heart for this industry, and I think it's probably the most exciting subsegment of the semiconductor business over the next couple of years. I guess to your point earlier about the roller coaster this year, it's been nothing shy of that. As I think Richard said, in the second quarter of this year, due to shutdowns of manufacturing, stay-at-home orders, et cetera, you had production that was dropping at certain points by almost 100% year over year in certain regions. A lot of the semiconductor companies originally guided for upwards of a 40 to 45% drop in year over year semiconductor industry automotive revenues in the second quarter. Thankfully, that got better. And it didn't end up being as bad as that. But the chart I'm showing on the screen here is really more about the automotive production. You can see the different regions of the world. All of them had their dips, Greater China being a little bit earlier. And the rest of the world, really, the second quarter was the trough. Thankfully, things have roared back. And it's not an exaggeration to saying roaring back. Again, as Richard said, there are significant issues about shortages. And so in the semiconductor space, it's either feast or famine at all points in time. The same companies that said, we don't want any chips, shut down all your production in 2Q, now are saying, where are all our chips? We need more than you can make. Unfortunately, the cycle times to make a lot of these chips can be 3 to 4 months. So it's not quite as easy as just flipping on and off a light switch. But the roller coaster was definitely exciting this year. I'm glad to have that sort of excitement in 2Q behind us. And again, it ended up being better than feared during that period. If we start to look beyond just the cyclicality of this year and the COVID impact and go to the next slide, the bigger long-term dynamic that some of my other panelists talked about, and I can highlight here as well, is the secular growth of content in vehicles, semiconductor content. In this chart, we just compared a basket of about 40 of the largest semiconductor companies in the world that break out their automotive revenues on a quarterly basis. We compare how those grow year over year each quarter versus the unit growth in SAR. And what you can see in this chart really simply is the blue column is above the gray column in almost every instance. The only times it's not is when you have some pretty significant inventory digestion periods. But generally speaking, you're growing faster in semiconductor revenue growth than you are in unit production growth from the automakers themselves. And that is the content increasing. Hopefully because we are both doing the math and it's not just convenient. I also agree that you tend to grow about 6 to 8% above SAR tends to be how much faster the automotive semi group is growing relative to the automotive production. But as you can see in this line, to me, the important part of this chart is really, first and foremost, you grow fast. Automotive semiconductors grow faster than the unit growth of the industry itself. That's the content increase. The second is that there still is cyclicality occurring in this. You can't be immune from the end market you're serving. But even in 2Q, where the production was down 43% year over year, you still had only a 27% decrease in this basket of companies for the semiconductor revenues. So you still outperformed even in the worst of times. You'll have a little bit of a harder time in 2021 catching up to demand year over year in the second quarter, but that's just more about the math of how bad the denominator was. So first point in this is you're taking share within the overall vehicle, content is growing. The second point is you're still cyclical. You're just kind of evolving from a purely cyclical industry from a semiconductor perspective to more of a growth cyclical industry. And hopefully investors will follow suit with that. So as we think about that content increase, the next logical question is really what's driving that, no pun intended. Some of my other panelists talked about these same features. You can even see some of the sourcing of this comes from our friends at Infineon. You can see that you have anywhere between a 2 and a 5x increase in the amount of semiconductor content per vehicle when you go to an electrified drivetrain. The EVs versus the ICE internal combustion engines have significantly more content in a lot of the manners that the other panelists talked about. But the key message here is electrification is a very big tailwind for the semiconductor industry. Certain parts of it will be 2x the content, others will be 5x the content, but it's a tailwind across almost every aspect. And that's something that will last for many, many years. If we went back in time, each year we at DB hold a global auto tech conference. We've been doing it for 5 or 6 years now. At the beginning of that process, most people were focused on the ADAS and really the full autonomy. The dream of a car comes and picks you up. There's no driver. It takes you where you want to go. And then you get out and it goes away. You only need one car per household because you don't have all the inefficiency of the car sitting in the garage 90% of the time. While that's exciting and sexy, it's really this electrification side that truly is getting the traction first for a wide array of reasons, not the least of which is the government incentives to do so after Dieselgate and some of those other carbon emission initiatives that are putting into place. But either way, this is a great trend for semiconductors, and it will continue over at least the next decade or so. And a lot of the mandates, even here in California, over the next 10 to 15 years, they're going to be banning internal combustion engines. So this is a great tailwind for semiconductors. The other large one to look at that some of the other panelists talked about is more the ADAS and autonomy side of things. Again, you could have significant content going from $200 a car to almost $1,000 a car, depending upon which of these metrics you're talking about, the different features between the sensors, whether they be camera, LiDAR, radar, sensor fusion, actuators. You can put processors into this equation. There's a ton of content that's needed. From my perspective, the interesting part about this move is trying to find the companies that actually evolve with this. The revolution that we were excited about 5 years ago, 6 years ago, about going to full autonomy and leapfrogging a lot of these interim steps, for a number of reasons, just doesn't seem to be happening. I think there's safety concerns, there's regulatory concerns, there's insurance issues, but I think it'll continue to head in the right direction, but be much more of an evolution than a revolution. We had debates 5 years ago when we held our first Auto Tech conference about whether the kids that were 5-10 years old would even need to learn to drive a car because things would be fully autonomous by the time they were of driving age. And that was 5 years ago, and people still need to drive their cars now. So to me, the interesting part is finding the chip companies that can evolve with this and add content as you go from L1 to 2 to 2 plus to 3, et cetera. But another great trend, this one is just taking a little bit longer to get to the full dream of autonomy for a lot of the reasons I discussed and the other panelists discussed as well. So that's really it from my side of things. Flan, let me just pass it back over to you.
Great. All right. Awesome. Thank you very much, Ross. We're going to go ahead and turn for the balance of the hour to Q&A. I encourage the audience to submit questions. There's a Q&A button if you'd like to submit a question there, and we'll try to get to as many questions as we can. I thought I'd kick it off initially just sticking with you, Ross, because I know you put a lot on the table, especially about the unique aspects of the automotive market, given that you look at the overall picture of semiconductors and other end markets, computer, communications. Can you give us a little more sense on, again, how the automotive end use is unique compared to those other end markets, and specifically, for example, sort of the vendor-customer relationship? I know obviously the types of chips that go into cars, for example, probably have more requirements than ones that maybe go into your phone, right? Because of safety issues and others. So can maybe sort of unpack that a bit?
Sure. Yeah, and I think it's a fascinating evolution that's happened in this industry. Like I said, when I first started covering semiconductors in the late 90s, everything was the big buzzwords in the dot-com bubble and all of those things. At the time, you didn't know it was a bubble, but the dot-com period, and automotive soon thereafter was something companies were exiting, not entering. It was a consolidated customer base. They hammered you on price all the time. It just wasn't fun to deal with. It's amazing how much that's shifted from a price-centric argument and relationship back then to 20 years later. Now it is a performance-centric partnership more so than a relationship. So I think for the semiconductor industry, that evolution of the importance of semiconductors to where cars want to go, they don't differentiate as much by horsepower. Now they differentiate by user interface, infotainment, safety, all electronically delivered features. and the fact that these life cycles of these products are so long. The design in cycle, first you have to get the design win, that takes years of work. Then once you get the design win, it takes years to get to production, and then that production goes for years. So these are very different than the once a year sprint that you would have in areas like PCs and handsets. These are long-term partnerships. And I think the automotive companies and the tier one companies are looking for the semiconductor companies to truly bring technology to the table, not just in piece parts, but in total solutions. So I think it's much, much more cooperative. And so these trends that I highlighted that can last for the next decade or so are ones that are very predictable, very competitive, and very difficult. It's not as if the auto companies want to pay more for every chip if they have a choice, but they realize that chip guys are going to be their driver of evolution and their driver of differentiation. So much more cooperative and much more dependent on the semiconductor industry than they've ever been before.
Yeah, I like it reminds me of on one of Bill's charts of how the components is the very foundation of sort of the building of how sort of the interaction with the other companies that are involved in automotive components. Wanted to get back to you. I know we've alluded to this in sort of passing, Richard. There are a couple, I guess, again, unique features of the auto end market that are probably a bit different from other components of semiconductor end markets, such as PCs or computer or cell phones. And that has to do with a lot of issues that are, quite frankly, policy issues. We talk about safety. That's something that governments care about, right? And regulate. We talk about privacy issues. Even clean environmental issues, right? And they all intersect in a unique way with the auto end market and what chips can enable than say some of the others other end markets arguably. Can you give us a sense again, sort of how the technology trends have intersect with these sort of broader policy issues that may concern states and governments?
Sure, that's a very good point, because it has, it may have a feeling of being a bit more of the Wild West unless it's brought under control. There's no doubt about it. I mean, Bill mentioned trust. I think it's a key, a fundamental that is required, particularly as we move towards autonomy. And we're seeing this, the WNECE WP29 regulation. Sorry, a bit of a mouthful, but the regulations that have come out of that are kind of shorthand known as WP29 are really key, because they regulate all aspects of 2- and 4-wheeled vehicle sales in the future. And amongst many of the requirements is basically around software updates, and particularly cybersecurity. The reasons why, of course, is we're moving inevitably, regardless of what we're developing today, towards a future which is autonomous. It started all the way back with automatic transmission, and we're a long way along from the 1940s when that came out. But it really would be a nightmare if this vehicle that you're going to be traveling in the future was not safe, and you didn't feel safe in it, and you felt that it was perhaps vulnerable to outside attack. And so OEMs are in a difficult position, because they're going to need to offer flexible platforms that kind of comply with these mandates kind of for free. Can't really charge customers, and they also need to offer these kind of upgrading opportunities to offer autonomous functionality. At the premium level, companies like Tesla, for example, they have standard hardware across most of their range, and their differentiation actually is mainly in software already. Really, it's been a kind of a touchstone that they've had from the beginning. But this allows you to kind of add features and functions. But the key point is that these requirements to kind of update a vehicle are going to be based on one predication, which is they must have over-the-air update capabilities, and you need to be able to update the software, and this is where this WP29 compliance comes in. We need to have a rigorous kind of paper trail in case things go wrong. I mean, the reality is, cars can be pretty unsafe or would become potentially, and we've already seen cases where software has been behind some fairly serious issues that have faced vehicles on the road, and the requirement to be able to get in there and update them needs to be tracked. What we don't want is people papering over the cracks about software that's been released. We need that, and WP29 really does that. And we need to move, and I think we'd like to move as an industry towards ADAS as a commodity. But then you'll hear the kind of naysayers saying, well, ADAS is a commodity. I mean, once again, that needs to be monitored. The fact is that if we have advanced driver assist systems all the way down to kind of entry-level vehicles, we are likely to see potentially some fairly serious bugs, if stuff's kind of just pushed out there. So the idea of ADAS as a commodity is not like other things. It's not like adding just another feature. This is a stepping stone towards a future where cars are driving themselves, and what the industry needs to do very much is adapt to that, because we're going to be moving into an environment where, as we heard earlier, there's a lot of sensor fusion and the incorporation of multiple features and functions into very powerful ECUs, all sitting on very powerful application processors, which are going to sit behind all this. So we're going to see less boxes being pushed into the market, with much more complex software that needs to be tracked and maintained. I personally don't want to be getting into the smartest car in the world that I don't feel safe in. So that's the safe part of it is kind of quite important for me before I can get in that car and shut the door.
Gotcha. Interesting. Yeah, I want to get Heinz Peter and Bill in here. I want to first ask you, Heinz Peter, a question about, you mentioned briefly architectures that will address consumer adoption challenges such as cost and range anxiety, I suppose, with electric vehicles in particular. What type of semiconductor technologies do you think are needed to make hybrid electric or electric vehicles more affordable, and particularly that question of range anxiety, or just moving over to a whole new type of car, right? That's a big step for a lot of consumers, right?
That's true, Felon. It's a big step. The cost and the range, they are obviously absolutely important, and the cost savings across the vehicle, it can be actually achieved through technologies that scale across an entire fleet with significant redesign time. And this is actually relevant for the hardware and also for the software side. For example, we've had a recently released functional safety compliant isolated gate driver. It's called the UCC 5870. It includes a programmable SPI. It's a serial peripheral interface, which can be configured across multiple platforms, and nearly any silicon carbide MOSFET, IGBT can actually be driven with this single driver in this configuration. This will help. The scaling is important at the end. So regarding the range anxiety, an EV ultimately needs to be comparable in range to combustion engine cars, which typically range maybe between, 300, 500 miles, depending on the type of vehicle as well. While there are many technologies and architecture decisions that can lead to longer drive ranges, one example could be, I mentioned this earlier, but wireless MCUs and battery management with a wireless protocol designed for battery management. And here, using technology to design a wireless battery management can significantly reduce weight from cabling. I talked earlier about the 3 miles of harnessing, right? So, and it's helping to extend the range. And our role and ambition at TI is to help car OEMs and tier ones really to develop the right product and solutions actually for them to have winning applications at the end, achieving longer drive ranges.
Got you. And one piece of that too, which I should raise, and if anyone wants to comment on this, that'd be helpful, is the infrastructure, right? The infrastructure that would go on with electric vehicles. I just, as a quick anecdote, the grocery store parking lot in our neighborhood I went there a couple of weeks ago, and lo and behold, I saw 2 EV charging stations just right there. And I thought, well, somewhere, something's happening either in the government or whatever that's coordinating to make it, again, reduce sort of that ranging anxiety and say, okay, hey, like we're building out that infrastructure. Anyone want to sort of comment on sort of how that plays a role in the whole sort of moving to electric?
I mean, at first also, if I may comment, Fallon, it goes down to the anxiety, range anxiety. The more of the infrastructure which is built out, right, the more comfortable the consumer feels actually. When I look in Germany, when you look at the forecast of the grid infrastructure to be built actually in the next years, it's huge. And this will help actually accelerating and fueling as well, and really reducing the anxiety around it as well.
Yeah, I wonder if at some point we'll see a tipping point and we'll all of a sudden see, a lot of folks just moving towards electric vehicles, or, a lot more sort of electric charging stations.
Just make one side point as well there, Fallon. There's a kind of a neat little side thing that's happened as a result of what we're seeing, which is an awful lot more time, unfortunately at the moment anyway, being spent on charging vehicles, maybe 40 minutes to an hour. It's being it's called kind of dwell time. And what's quite interesting on the infotainment side, particularly Tesla, I'm afraid they've picked this one up pretty quickly. But on a recent trip, one of the guys in our team has a Tesla Model 3, and he traveled to Vegas and stopped, and it has native Netflix built in. So he and one of his mates basically sat and watched Netflix while they were charging the vehicle. So this idea of dwell time is actually circling back to how we are actually designing the inside of the vehicle. You have a captive, you can either go into the mall or you can sit there and in the vehicle. So there are side issues that are kind of coming out, which are kind of very positive as well for the industry. Dwell time. Listen up for dwell time.
I wonder if the Tesla car is smart enough so that it doesn't allow the driver to actually watch Netflix while he or she is driving.
That's correct. It doesn't. As soon as you're moving, I'm afraid it's not available.
Get into that safety issue. Bill, speaking of safety, Bill Stewart, I wanted to touch base with you because I know that's an area that you focus in on at Infineon is the automotive safety features. Can you give us a sense? I'm curious. Obviously some of the new safety features, that come standard in cars now. Backup camera, really cool. Lane assist. I just love that thing. What does the future hold for safety? I mean, what's the world look like in the next 3 to 5 years in terms of new safety features where we should expect?
Yeah, I think Ross talked about the push out of level 4 and 5, right? And that doesn't mean the push out of ADAS, right? I think what we're going to see is once AEB, automatic emergency braking, becomes a standard feature in the US, the OEMs have agreed to do it in 2022. So you now are adding cameras, you're adding radars to vehicles. Those are used for multi-purpose, which now you can not only have braking, you have lane tracking. I think what you're going to see shortly, 2 things. One is the level 2, or the highway autopilot type features, the city autopilot. Under unique circumstances, that's going to become more of a standard feature, not standard. But there's a bit of a coupling between electric vehicles and level 2, level 3 vehicles. And it tends to be no one's coming out with a new EV that doesn't have a level 2 plus system on it, right? We've seen that being a key component of all of the announcements the OEMs have made. And so I think what you're going to see is the level 2 type systems are going to become standard. You're going to be able to have highway autopilots. So if you want to travel across the country in your EV, it's a lot more comfortable to do so. Maybe to come back to your previous question a little bit though, to me, I think the other thing with EVs is being able to get that dwell time from 40 to 60 minutes down to 5, right? And so I can just pull up to a rest stop, plug in my car, get a DC quick charge, and then keep going instead of having to sit there and wait for that 30 or 40 minutes. Having 200, 300 miles of range, I don't need to worry about range anxiety most of the time unless I'm on some sort of road trip. So.
Gotcha. Cool. Well, we are getting close to the top of the hour. I want to be sure we don't dwell too much further past that, but I did want to ask each one of you because this is an area where it's personally, it's super exciting. And I think for for the average consumer, they can see and feel and experience all the sort of enabling features that you have in cars these days compared to even 5 years ago, certainly longer. So what I thought I'd do is maybe just go around and see if folks can sort of highlight their most favorite application that is in a car these days that is being powered in some way or another by semiconductors. I know, Heinz-Peter, you mentioned your wife likes the automatic door lift, and I was going to just give a quick anecdote before I started mine. So I recently, my wife and our family bought a new car, a relatively new car, 2017, and we replaced a 20-year-old vehicle that we had that was a stick shift. And I was actually looking to buy a stick shift because I want to teach my kids how to use stick, and I thought it was an important thing. And also because I've always assumed that stick shift was more efficient in terms of, energy efficient fuel usage. But when I went to the dealer, I said, I want to buy a stick shift because it's more fuel efficient. First of all, they said, we don't sell stick shifts anymore. And second of all, they said, well, actually, today's automatic vehicles are actually more fuel efficient than stick shifts because of the technology. I was thinking to myself, because of that semiconductor technology, right? That's making the engine run more efficient. And they were said, basically, that's correct. So for me, with this new car that I have, I really do appreciate the energy efficiency that is being enabled by semiconductors. But let's just go down, maybe starting with you, Richard, and ending with you, Ross. But Richard, what would be your feature that you like with cars that's enabled by semiconductors?
Well, I think it's what Bill mentioned. I don't think the next car I buy will absolutely have to have autonomous emergency braking. I just think it's a fantastic technology, particularly good if you're sort of a little bit dozy in traffic, and it does stop you kind of rear-ending other people. For me, that gets top marks.
Okay, great. Heinz-Peter, how about you?
Well, for me, actually, also safety, being on the Autobahn, it's like adaptive cruise combined with steering. That's for me a must.
Okay. Yeah, I guess I haven't had the opportunity to drive on the Autobahn, but I suppose I definitely want my safety features up the if I were there. So
yep, you definitely do.
Yeah. Bill Stewart, how about you?
So I think it's 2-1. I think I have to say adaptive cruise and the lane keeping for my job. But I mean the other one that I really like living in a northern climate is the heated steering wheel. Something I when I first was told about it, I was like, oh, that's stupid. And then got in the car the first time it was cold and said I can never have another car without this. So
yeah, interesting. Yeah, I like heated seats, heated steering wheels. Oh my God, it's this new car is, it's like I told my wife, it's like going from a horse and buggy to a rocket ship, in a span of like 20 years from our 20-year-old car to now. So Ross Seymour, how about you? Get the last word here. Favorite feature?
The father of 3 teenagers who will be driving relatively soon, safety features are key. AEB, massively true, because I don't want them hitting stuff. Driver monitoring, some of the sensors that'll be looking at the driver to make sure they're not falling asleep, making sure they have their eyes on the road. Lane monitoring. So basically anything that keeps those kids from driving like I drove when I was their age, I want that to be automated.
Oh, yes. Amen. Amen on that, definitely. So, all right. Well, good. I appreciate we're at the top of the hour here, a little over, but thank you all. Richard Robinson, Heinz-Peter Beckmeyer, Bill Stewart, and Ross Seymour. Thank you all for participating, and we'll see what the future holds for automotive end use for semiconductors. Thank you very much.
Thank you.
Thank you.